This is lesson number 23 on Introduction to Trigonometry. Our learning goals are reviewing how to use the sine, cosine, and tangent ratios to find missing sides and angles in right triangles, like we did in grade 10. And we're also reviewing how to use the sine law and cosine law to find missing sides and angles in non-right angle triangles or oblique triangles. In grade 10, we learned right angle trigonometry using the sine, cosine, and tangent ratio. So in a right angle triangle, the lengths of the sides and the measures of the angles are related by the trig ratios. So in this case, according to angle A, if we label from angle A is one of the acute angles in a right angle triangle, so a triangle that has one angle that measures 90 degrees. The side across or opposite angle A is called the opposite side. The side across from the right angle, we know from the Pythagorean theorem and also from last year, is also always called the hypotenuse. And then the side that helps form angle A with the hypotenuse is called the adjacent side. And the trig ratios are the sine of angle A. So you saw earlier that sine is spelled S-I-N-E, but when we are using it, we just use the short forms S-I-N, sine of angle A, is equal to the length of the opposite side over the length of the hypotenuse. The cosine of angle A is equal to the length of the adjacent side over the length of the hypotenuse, and the tangent of angle A is equal to the length of the opposite side over the length of the adjacent side. And these three formulas can be used to find missing sides and angles in right angle triangles if we use them appropriately. So we're going to review some questions that we worked on last year. So the question is to solve for the indicated value. So here we see we're trying to solve for side DF. So here's side DF that we want to know what it is. And this is the acute angle, the 51 degrees that were given in the question. So we want to label our sides according to the acute angle given in a right triangle. So according to the 51 degrees, the 17 meters would be the side opposite. DF, because it's across from the right angle, would be our hypotenuse. And then side DE, that helps form the angle 51 degrees with the hypotenuse, we would call the adjacent side. Now in every calculation, when we're finding a missing side, two of the sides are going to be involved in the ratio and the third one is not. So in our case, 17 meters, or the opposite side, is going to be involved because we know its length is 17 meters. And because we're trying to find DF, or the hypotenuse, it's going to be involved. And the adjacent will not be. So we want to know the formula, the trig formula, that has opposite and hypotenuse involved in it. So if we go back up here for a second, you can see that it's the sine ratio that has opposite and hypotenuse. So we're going to use that formula. So sine of the angle in this case that we're talking about is 51 degrees, is equal to the length of the opposite side, which is 17 meters, over the length of the hypotenuse, which we don't know, so we'll just call it side DF. And then we would like to solve that and get DF by itself. Since DF is in the denominator, the first thing we want to do is get it in the numerator. So we're going to multiply both sides by side DF. And those will cancel. So then we'll be left with DF side times the sine of 51 degrees, which is a number that you can get from your calculator, is equal to 17. So then if I want to get DF by itself, I would divide both sides by the sine of 51 degrees. And then if I use my calculator effectively, I will be able to figure out the length of DF. So every calculator is different. One thing you want to do is make sure you're in degrees on your calculator. So some calculators that will be a DEG, some will be a capital D, and you can use either the mode button or sometimes some calculators have a button that says DRG, which really means degrees, radians, or gradians, and you want to press it until you see degrees showing up. If you do it correctly, so on my calculator, I just simply type in 17 divided by the sine of 51 degrees and then press equals, and it will give me 21.87, but we'll round that to 21.9 and then look for units here, meters. Okay, so the length of DF is approximately, that's why I have a dot here, 21.9 meters. On other calculators, you would type in 17 divided by 51 and then press sine. So test your calculator now and see how you can effectively type in 17 divided by the sine of 51 to get the answer 21.9 meters. So hopefully you've been successfully able to do that. If not, just pause the video until you have figured out or ask someone how to get that to happen on your calculator. We're going to move on to the next question. Again, it's solve for the indicated value. In this case, it's x that is unknown. And we see that it's a right angle triangle where we're given one acute angle, 18 degrees. So again, we're going to name the sides of the triangle according to the angle that we're given here. So the side opposite from the right angle is our hypotenuse, and we can use HYP as short form for hypotenuse. The side opposite the 18 degrees, we call the opposite side, OPP for opposite. And then the side that helps form the angle 18 degrees with the hypotenuse is called the adjacent side. So again, 2 out of the 3 sides will be involved in the calculation. The side that we want to find, so the adjacent side, and the side that we know, which is the hypotenuse. So we want to find the trigonometric ratio that has adjacent and hypotenuse in it. So we go back to our formulas and we see that adjacent and hypotenuse is the cosine ratio. So we're going to do the cosine of the angle. In this case, our angle is 18 degrees, is equal to the adjacent side, which is being called x right now, over the length of the hypotenuse, which is 12. And we want to find x. We want to get x by itself, so we can multiply both sides by 12. And then we'll know that x is approximately, and then again on your calculator, you want to be able to do 12 times the cosine of 18 degrees. So some calculators, you press cosine first, others you press the 18 first. But either way, you should be able to get 11.41, but we'll round it to 11.4 meters approximately if you use your calculator effectively. So still with the question, solve for the indicated side. So we're on question C now. And it wants us to find an angle this time, angle A. So if they want you to find an angle, then you label your triangle's sides according to the angle that you're trying to find. So here's angle A that I'm trying to find. So I'm going to label the sides according to angle A. So I know that the side across from angle A is called the opposite side. The side across from the right angle is always called the hypotenuse. And the other side is called the adjacent side. In the case where you're finding an angle, you want to keep the sides that you know the information about. So we know the opposite is 16 and we know the adjacent is 20. We don't know the hypotenuse, so we're going to ignore that for now. So then we want the trig formula or the trig ratio that involves opposite and adjacent. And if you go back to the last page, you'll see that it's tan of angle A is equal to the opposite divided by the adjacent. So that's the formula we're going to use. Tan of, we don't know the angle, that's what we're trying to find. So we'll just call it angle A because that's the name of it, happens to be angle A, is equal to the opposite, which is 16, divided by the adjacent, which is 20. Now, we now know that the tan of angle A is 16 divided by 20, but we want angle A. So we want an operation that, right now the A or the angle is being trapped by tan, and we want to undo tan. Well, you can't divide by tan because tan is a function. It does something to the angle. So we want to undo the tangent, And the way you do that is you take the tan inverse. So that little inverse, tan inverse undoes tan. But if we do it to one side of our equation, we also have to do it to the other side of our equation. So we take the tan inverse, this little negative one that means inverse, we just finished that unit, of 16 over 20. So that all I'm left with then on the left side is angle A. So tan inverse undoes tan. And on this side, we actually can use our calculator to figure out the tan inverse of 16 over 20. So it depends on your calculator. On my calculator, I press second tan, and then a bracket opens up for me. And I do tan inverse of, and then I inside my bracket, 16 divided by 20, closing bracket equals. And it says 38.65, but approximately, and usually with angles we round to the nearest degree, 39 degrees. On other calculators, you would go 16 divided by 20, so 16 divided by 20 equals first, and then you press shift or second, and then tan, which will bring up the tan inverse function. So 16 divided by 20 equals, and then you take the inverse tan of that. Either way, you should be able to get 39 degrees if you are able to use your calculator correctly to find the angle. All right, now we're on to question D. In this case, they want us to find the length of side BC. So I could just call it X if I want here. It's a right angle triangle again, I notice, and I'm given this angle 23 degrees. So I'm going to label my sides according to the 23 degrees. So the side opposite 23 degrees is the opposite side. And we know the side opposite the right angle is always the hypotenuse. And the side that helps form the angle with the hypotenuse is adjacent side. So in this case, we want to know X, so it's in, and we know the hypotenuse, so it's in. So we want the ratio that involves opposite and hypotenuse. And if you look back on the page before, you'll find that that is the sine. So the sine of the angle, and the angle in this case is 23 degrees, is equal to the length of the opposite side, which we're calling X, over the length of the hypotenuse, which we're calling, or which is told to us as 40 feet. So then to get X by itself, we're going to multiply both sides by 40. And then if we use our calculator properly, we're going to do 40 times the sine of 23. And you should get approximately 15.6 feet. Okay, so that's a review of using SOHCAHTOA. So why do we say SOHCAHTOA? If you remember from grade 10, SOHCAHTOA is for right angle triangles. And that's a little acronym, I guess, that says that sine, so S, is opposite over hypotenuse. So that's the O and the H. Cos is adjacent over hypotenuse. So cos is adjacent over hypotenuse. And tan is opposite over adjacent. So SOHCAHTOA helps you memorize the three formulas for right angle triangles. And remember, these are just for right angle triangles. They do not work for triangles that don't contain a right angle. So that's what we're going to move to next. Also in grade 10, we learned the sine law and the cosine law, and that they can be used to find missing sides and angles in oblique triangles or triangles that don't contain a right angle. The sine law states that in any triangle, the ratios of the sines of the angles to the lengths of their opposite sides are always equal. So the sine of angle A over the length of its side, the opposite side, is equal to the sine of angle B over the length of its opposite side is equal to the sine of angle C over the length of its opposite side. Or you can just flip everything upside down and have the length of side A over the sine of angle A equal to the length of side B over the sine of angle B is equal to the length of side C over the sine of angle C. They're the same formula, just flipped upside down. You would want to use this version if you were finding a side, And the reason is because the sides are located on top where it's easier to solve for them. And you would want to use this version if you were trying to find an angle using the sine law. And then we've got over here is our triangle. So a typical non-right angle triangle, if you label the angles with capital letters, A, B, and C, then the sides are the corresponding small letter opposite. So if this is angle A or side little a would be opposite to it. If this is angle B, side little b would be opposite to it. And if this is angle C, side little c would be opposite to it as well. So now we're going to practice using the sine law. So our first question asks us to use the sine law to find the indicated measurement. So in this case, they want side VT, which we could also call side little u because it's the side opposite from angle U. Just make sure your little letters look different from your big letters. And rather than thinking about the sine law as it always has to be in terms of A, B, and C, we want to think of it more as a pattern. So the length of a side divided by the sine of the angle opposite of it is constant for all three sides and angles. That's how you want to think of the sine law. You don't want to rename all the sides A, B, and C every time and all the angles A, B, and C every time. So let's look back at this question from that standpoint. So to use the sine law, you need to know an angle and its opposite side. So I could look at, do I know angle T? No. And I don't know its opposite side either. Do I know angle V? Yes, I know angle V and I know its opposite side. So that's my known ratio. I know angle U and I'm trying to find side U. So this is set up perfectly to use the sine law because it's a side, U in this case, over the sine of the angle opposite to it, which is sine of angle U, or the sine of 36 degrees, is equal to side little v in this case, which is 13, over the sine of its opposite angle, or the sine of angle V. So we can go straight to saying U divided by the sine of 36 is equal to 13 divided by the sine of 65. And then all I need to do is get U by itself. It's being divided by the sine of 36, so we want to multiply both sides by the sine of 36. So those cancel. And then if we are just able to use our calculator effectively, we can figure out the length of side U. So I'm going to do 13 times, on my calculator I press sine first, the sine of 36 equals divided by the sine of 65 equals. And I get U is approximately 8.43, but I'm just going to round that to 8.4. And then you look for the units in the question, inches. Okay, so that's the length of side U. Other calculators, you might have to do 13 times 36 and then press sine. And then equals, and then divided by 65 sine, and then equals again. So it depends on your calculator. This is just what you would type. But you should be able to use your calculator effectively to get 8.4 inches. So I'll give you a moment to make sure that you can get that on your calculator. If you can't, please pause the video and ask somebody for help that remembers from last year, somebody familiar with your type of calculator. So remember, for the sine law, you always need to have what I call a side angle pair. If you don't have a side and its opposite angle, then you cannot use the sine law. Okay, side angle pair to use sine law. All right, let's look at our next example of the sine law. So in this case, it says use the sine law to find the indicated measurement again. This time they want us to find angle D. So first time if I was said, okay, use a sine law to find angle D, I would assume that I would know the side opposite angle D, but I don't know it, okay? So I can't use the sine law right now to find angle D directly, but if they told me to use the sine law, there must be a side angle pair that I know. So let's look at C now. I know angle C, check, and I know side little c, check. So I've got the side angle pair of C's. I also know side little b, which means I can use the sine law to find angle B. And then one rule that hopefully you remember from grade 10 and even grade 9 is that if you know two angles in a triangle, you can subtract from 180 to get the third angle. So that's going to be our strategy for getting angle D. We're first going to find angle B. So our plan is to find angle B using the sine law. And then step 2, we'd find angle D by making it 180 degrees minus angle C minus angle B. Okay, so we're going to carry that plan out, finding angle B. So if I want to find angle B, I want to start off my sine law with angle B on the top because it's easier to solve for something when it's in the numerator. So the sine of angle B, it's got to be divided by the length of the opposite side. So here's angle B. The side opposite little b, it's got a length of 5. So if we start off with the angles on top on this side of the equation, we have to start off with the angle on top on this side of the equation. So the angle we know is angle C, so we're going to do the sine of angle C, which is 49 degrees, over the length of its opposite side, which is 3.8. So we can multiply both sides by 5 to get the sine of B by itself. So the sine of angle B is going to be 5 times the sine of 49 degrees divided by 3.8. But they definitely do not want to know the sine of angle B. They want to know angle B. So again, to undo sine, we do this special inverse function, sine inverse. You'll see that it's a button on your calculator. Usually it's above the sine button. So if we take the sine inverse of one side, we have to take the sine inverse of the other side. So the sine inverse of sine B, all sine inverse does is undo sine so that you're left with just angle B on this side. And then this is something that we can type inside of our calculator. It's a number, and that number represents the angle, the length of angle B, or the size of angle B in degrees. So different calculators do it different ways. In some calculators, you're going to do 5 times 49 sine divided by 3.8 equals, and then you're going to press shift or second and then sine. In my calculator, I can actually press shift or second and sine first, and it opens up a bracket for me. And then inside that bracket, I can type 5 times the sine of 49 degrees divided by 3.8. Close that bracket they opened up for me, and it will go directly to give me the angle, which says 83.2, but we usually round angles to the nearest degree, so I'm going to say approximately 83 degrees. So that gives me angle B, but the question asked for angle D way up here. So angle D, we know is going to be 180 degrees minus angle C, which was 49 degrees, minus angle B, which we just found. So if we type those in our calculator, we're going to get approximate number for angle D since we rounded angle B. So I'm doing 180 minus 49 minus 83, and I get approximately 48 degrees. And now I have angle D. Okay, next question, using the sine law again. So this time they want me to find side ST, which we know we could call, since it's across from angle, our little r. And notice here we have 2 angles in a triangle, which means we actually know 3 of them. So right away, whenever I see that, I'm going to go 180 minus 65 minus 55, just in case I need this angle. So I actually know it's 60 degrees. And this is what I'm trying to find, little r here. So I know it's opposite angle, so I'm going to start off by saying little r divided by the sine of 60 degrees, and I put little r on top because it's the side I'm solving for this time. And the pair that I know, so I know angle S and side S, so I'm going to set that equal to, I need the side on top, 21 divided by the sine of 65 degrees. Again, I need to get little r by itself, so I'm going to multiply both sides by the sine of 60 to undo that divide. And then I'm going to get r is approximately, I'm going to use it, my calculator correctly, so 21 times the sine of 60 degrees equals, divided by the sine of 65 degrees equals. And I get approximately 20.1, it's a side length, 20.1 millimeters, since that was what the sides were measured in for this question. And then I would probably, since they asked me for ST specifically, then I'd go a step further and say therefore ST is approximately 20.1 millimeters. Next question, they're asking for an angle this time, angle L. And again, you notice that we don't have side little l. So we're probably going to have to find side K, our angle K first, because we do know side little k, we know angle M, and we know side little m. And then we can use the 180 minus again to get angle L. So we're going to start off with the sine of K on top, because we want to find angle K to start with, over its corresponding side, so 87.8 equals the sine of angle M, which we know is 85 degrees, over the length of the side opposite to it, which is 100 millimeters. So I want to undo divide by 87.8, so I'm going to multiply both sides by 87.8. So I get that the sine of angle K is equal to 87.8 times sine of 85 degrees divided by 100. And I know that I have to take the inverse sine of both sides to get angle K by itself. Some people just go straight to saying they know that angle K is going to be the sine inverse of 87.8 times sine 85 degrees divided by 100. And that's okay to do in grade 11. But you do have to be able to enter that into your calculator effectively. So depending on your calculator will depend on whether you do the 87.8 times 85 sine divided by 100 first equals and then press inverse sine, or whether you can start off by pressing second sine or shift sine or inverse sine depending on your calculator. So I'm doing the calculation right now. And I get that angle K is approximately 61 degrees. But I actually was asked to find angle L, which we know is going to be exactly 180 minus angle M minus angle K. But then if I put that in my calculator, since angle K is rounded, my answer is going to be approximate. So 180 minus M, which was 85, minus K, which was, we just found to be 61. So angle L is approximately 34 degrees. Okay, now we have a word problem, the diagram here. Determine the distance from the Colt station to the fire. So let's look at our diagram here. Here's the Colt station right here. Here's the fire. That's the distance they want, so we could call that X. That's what they want us to find. We know the distance from Pine Knob to Colt Station is 30 kilometers. And then they give us an angle here between the vertical, like straight down, and the side we're trying to find as 70. And they also give us some angles here from the start. Namely that from the tower to our first line of sight here is 65 degrees, and from vertical to our second line of sight is 80 degrees. So that's going to tell us a couple things. First of all, the angle between the two is going to be 80 minus 65, which is 15 degrees. And also, we're going to form get a highlighter here, a Z pattern. So if we go straight south, and then along this line, and then straight south again, we've got a parallel line theorem Z pattern, which makes this angle here which is 65, and this angle here, so like the underarms of the Z, equal to each other. So that makes this angle in here 65 degrees. So that this total angle here is going to be 65 plus 70 degrees, which is 135 degrees in there. So now we know this angle is 15, and that's 135. So if we subtract from 180, we've got 180 minus 135 minus 15, and then we actually know this angle over here is 30. So we know all three angles, and we know that one side, so we can get side x then, using the sine law. So we're going to start off with x on top, over the sine of the angle opposite, which is the sine of 15 degrees, is equal to the side we know, 30 kilometers, divided by the sine of its opposite angle, which we figured out was also 30 degrees. All right, so now we want to get x by itself, so we're going to just multiply both sides by the sine of 15 degrees. And we get that x is approximately, so 30 times the sine of 15 divided by the sine of 30. Please make sure you are able to do this on your calculator. Please ask somebody for help if you are not getting the correct answers. And then since this is a word problem, we should do a little sentence then. Therefore, the distance from the Colt station to the fire is 15.5 kilometers. Okay. All right, so the sine law we realized has limitations in that we need to know a side angle pair in order to be able to use it. So it doesn't solve every oblique triangle because there are some oblique triangles where we don't know a side angle pair. So there has to be another way to find missing sides and angles, and that is the cosine law, which we also learned in grade 10. I always like to think of the cosine law. It starts off like the Pythagorean theorem, a squared equals b squared plus c squared, but then you subtract 2 times side b times side c times the cos of angle A to account for it not being a right angle triangle. And again, I want to think of it as a pattern. So I'm going to show you. If we start with side little a, then we end with angle A. And then sides B and C appear here, like as if it was the Pythagorean theorem, but also when we're subtracting that 2 times B times C. So I could write any iteration of the cosine law. So if I started with little b squared, side little b, it would be the sum of the squares of the other two sides, so a squared plus c squared, minus 2a and c again, 2 times a times c times the cosine of angle b. So the angle opposite the side you start with again. So it's a pattern. And then also it's important to note that this term is 4 things multiplying together. So we have 2 multiplied by side A, multiplied by side C, multiplied by the cosine of angle B. And those are all numbers. Side little a, side little c, and then the cosine of angle B is a ratio that your calculator stores. So they're all numbers that you're multiplying together. And same thing, I could start this off with c squared, and hopefully you guys would be able to say, if I start with c squared, it's going to be a squared plus b squared minus 2ab times the cosine of angle C. You use the cosine law in the case where you're given all three sides. So if the information you're given is all three sides or side, 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 you have to use the cosine law. Or if you're given two sides and the contained angle, which we call side angle side. So that would be the case where you're given, here's your triangle, you're given two sides, so you know this side, you know this side, and you know the angle between them, but you don't know anything else. You would use the cosine law. And you would actually use the cosine law to find the side opposite the angle that you're given. So we call this side angle side, two sides in the contained angle. The cosine law allows us to find an angle when all three sides are given. So here's a case where all three sides are given. One thing that's important to know is that the cosine law gives you angles all the way from 0 to 180, whereas the sine law always sticks to angles between 0 and 90. So if there happens to be an obtuse angle in your triangle, you always want to use the cosine law to find it. So the other thing to notice is that if you think about it logically, the largest angle in a triangle is always between the two shortest sides. And you kind of learn that in grade 9 and grade 10, even when we talked about the Pythagorean theorem. Because in a right angle triangle, that 90-degree angle is the largest. The hypotenuse, the side opposite, is always the largest side, and the other two sides are shorter. So if any angle is going to be greater than 90 degrees or obtuse, it's going to be the angle between the two shortest sides. So in this triangle we have here, if we wanted to know if any of these three angles were going to be greater than 90, it would have to be the one between these two shortest sides here. None of the angles would be possible for them to be obtuse, because if you think about it, you can't have a triangle that has more than one obtuse angle in it. You can't even have a triangle with more than one 90-degree angle in it. Okay, so let's find this angle here. So we could call it angle A. So if we want to find this angle that we've called angle A, the format of the cosine law we're going to use is the one that starts with the side opposite, so that we end up with angle A in our formula. So I'm going to start off without even writing a little a down. I'm going to start off with 5.9 squared equals, so the other two sides each squared, like the Pythagorean theorem, 3.1 squared plus 4.3 squared. Then minus 2, it's a pattern, times 3.1, so one of the other two sides times the other one, times the cosine of the angle between them, which was A. Okay, so now we slowly want to get angle A here by itself. So again, this whole term here is four numbers being multiplied together. And when you solve or you isolate for a variable, you always use reverse BEDMAS. So we want to undo any adding or subtracting to angle A before we undo multiplying, dividing, or cos even, okay? So in this case, the 3.1 squared is adding to this term that contains angle A. So we're going to subtract 3.1 squared on both sides. And I'm just going to let my calculator do the work for me there. But I'm also going to subtract 4.3 squared on both sides. And again, let the calculator do the work for me. So I'm going to type into my calculator 5.9 squared minus 3.1 squared minus 4.3 squared. And that gives me 6.71. So now these are gone and these are gone. And I'm left with this one big term here. It's got three numbers that I know times the cosine of angle A. So I'm going to multiply those three numbers together. So negative 2 times 3.1 times 4.3. That gives me negative 26.66 times the cosine of angle A. So again, this number is multiplying the cosine of angle A, and I want to undo that, so I'm going to divide both sides by 26.66. Negative 26.66, my apologies. So that's going to leave me with, if I just switch sides here, that the cosine of angle A is going to equal this number, which is not a friendly number, so we're just going to leave it. And I can move the negative to the top, so negative 6.71 over 26.66. But that's the cosine of angle A. We just want angle A. So angle A is going to be the cos inverse of 6.71, negative 6.71 divided by 26.66. And then you just have to be able to put that into your calculator properly. So depending on your calculator, you might do negative 6.71 divided by 26.66 equals, and then shift or second and cos. Some calculators you start with second and cos, and then negative 6.71 divided by 26.66. And I get 104.5, so approximately 105 degrees. So in fact, this was an obtuse angle, bigger than 90, 105 degrees. Okay, so that's the way you can use the cosine law to find an angle when all three sides are given. Okay, so pick the angle you want to find, and then you start off the cosine law pattern with the side opposite to it. You can also use the cosine law to find the side opposite the one angle that's given. So here's our case where we have side, angle, side. So we know these two sides, we know the angle between them, but we don't know the side opposite. So in this case, we're finding a side, and we're going to start with the side that we're trying to find here. So little r squared is equal to the sum of the squares of the other two sides. So 2.6 squared plus 6.9 squared minus 2 times each of those sides times the cosine of the angle between them, which we know is 117 degrees. So in grade 10, I focused on trying to get this whole entire number just in one time through our calculator. So you're going to type in 2.6 squared plus 6.9 squared minus 2 times 2.6 times 6.9 times, and then either 117 cos or cos 117 depending on your calculator. And if you type that in properly, you get approximately, because I'm going to round here, 70.65918 if you round. But that's r squared, and we want r. So then we have to square root both sides, and then we get r. Some people may be able to go straight to that, calculate this number, and then square root right away. That's okay in grade 11 if you can do that as well. So now I'm going to just do the square root of 70.65918, and it's approximately 8.4, and there's no units given. See, the 6.9 doesn't have any units, and neither does the 2.6, so we can just say units, whatever they happen to be. So that's using the cosine law to find a side. Okay, so we're going to do some practice then using the cosine law. So the first question, find the largest angle in the triangle. So look, we're looking at triangle LMN, and we did say that the largest angle would be between the two shortest sides. So we have a side that's 12, a side that's 10, and a side that's 8. So the angle between the 8 and 10, or angle N, is going to be the largest angle. So if we want to find angle N, we start off our cosine law with a side that's opposite to it. So I'm going to start off by going 12 squared equals, and then each of the other two sides, doesn't matter what order, squared, minus 2 times 10 times 8 times the cosine of angle N. Okay, again, so we're using reverse BEDMAS to get angle N by itself. So we're going to undo this adding first. So we're going to subtract 10 squared on both sides and subtract 8 squared on both sides and let our calculator do the work for us. So I'm typing in 12 squared minus 10 squared minus 8 squared. That gives me negative 20. And then here, this is all one big term, so I can multiply the three numbers together that are at the beginning. Negative 2 times 10 times 8 gives me negative 160 times the cosine of angle n. So I'm going to, still trying to get n by itself, so I'm going to divide now both sides by negative 160. Switch sides here, so I get that the cos of angle n, two negatives make a positive, is 20 over 160. But that's the cos of n. I want angle n, which is going to be the cos inverse of 20 over 160. And then enter that into my calculator. And you get 82.8 or approximately 83 degrees. So even though it's the largest angle, in this case it doesn't turn out to be an obtuse angle, 83 degrees. All right, the next question, we look at it. Find the perimeter of the triangle to the nearest tenth of a centimeter. So perimeter just means that we have to know all three sides. We already know two of them. So once we get the third side x, we can add them together to get the perimeter. And this is a cosine law question because we know the two sides with the angle between them. So that side angle side pattern there. So I'm going to start off with side x that I want to find squared. So it starts off like the Pythagorean theorem. X squared equals 11 squared plus 21 squared minus 2 times 11 times 21 times the cosine of the angle between those 11 and 21 side, which is 73 degrees. So see if you can type this in and get a number. Give you a little bit of time to try that. So you'd be typing in 11 squared plus 21 squared minus 2 times 11 times 21 times the cosine of 73 degrees. And I got approximately 426.92427. And then I want to square root that. And again, you can go straight from here to here if you are able to with your calculator. Take the square root and you get approximately 20.66, so 20.7 centimeters. But that's not the perimeter. So then you've got to remember perimeter is going to be 11 centimeters plus 21 centimeters plus x. But it's going to be approximate because x was approximate. So 11 plus 21 plus 20.7, approximately 52.7 centimeters. It did say nearest tenth of a centimeter, so we've answered correctly there. All right, we've got 2 more problems to go, and then we've kind of reviewed all of grade 10 trigonometry, which took us about 2 weeks and 1 day. So airplane question, we might have done this last year, a ship question, leaving harbor, similar. 2 planes leave an airport at the same time. So here's our airport. This is north. So north is always straight up and down. South is opposite. East to the right and west to the left. There's my compass. 2 planes leave an airport at the same time. One plane is flying 575 miles per hour at a bearing north. So if it says north first, you're going north first. And then 23 degrees towards east. So I guess a couple things to know here is that from north to east is 90 degrees, so the halfway point would be 45. So if I'm only going 23 degrees to the east, I'm going less than halfway, okay? And the other plane is flying at 625 miles per hour at a bearing of north 65 degrees west. So again, 45 would be so north first. 45 would be northwest, so 65 is more than halfway towards west. Oh, that looks like halfway. So I want to make it look like less than, so more towards the west. Okay, and this one's flying faster, so it's going to be a bit longer. So how far apart are the planes after they've flown for 3.5 hours? So the one that's flying faster should have gone more distance in that time. So we can make a triangle here where we know this is 23 degrees and this is 65 degrees, so that we know that entire angle in here is going to be 88 degrees, 60, 70, 88 degrees. We also know, okay, so if a plane flies at 575 miles in 1 hour, then it'll fly 575 miles times 3.5 in 3.5 hours. So 575 times 3.5 gives me 2012.5 miles. So that means this first plane has gone 2012.5 miles in 3.5 hours. And then the second plane that's flying faster, 625 miles times 3.5 hours. So it's gone 2,187.5 miles. So I'm going to put that in over here, 2,187.5 miles. And we've got this setup of, we know this side, we know this side, and we know the angle between them, side angle sides. So we've got the cosine law set up for us to find this distance we can call d between where this plane is after 3.5 hours and where this plane is after 3.5 hours. So if we want to find that side, we'd use the cosine law, d squared equals, so our two sides, so 2012.5 squared plus 2187.5 squared minus 2 times 2012.5 times 2187.5 times the cosine of 88 degrees. So it's right down there. If you can go straight from here to the answer, go ahead. I'm still going to put that little middle step in here. So 2012.5 squared plus 2187.5 squared minus 2 times 2012.5, careful typing it in, times 2187.5 times the cosine of 88 degrees. That gives me a huge number here. So 8,528,033.338. So all my calculator will fit, but I've still got to square root that so the answer makes sense. And again, you can go straight here if you can. So square root of that is 2,920, and it says how far apart are the planes. It doesn't say how we have to round here, so I'll round to 1 decimal place. So 2,920.3 miles. Word problem, so let's do therefore after 3.5 hours, the planes are 2,920.3 miles apart. Okay. And our last question. Determine the value of h. So h is part of a right angle triangle, but so this is going to be 90 degrees as well. And we know this is 80. Guess we'd know that this one up here is 20. But we don't know any of the 3 sides right now. And in order to find any side of a right angle triangle, you need to know at least one of the other 2 and an angle. Right now we don't have that. We know this whole side here is 100. And then we know for this, the whole big triangle, not the right angle part, this angle's 30, this angle's 80, and we could find this whole angle up here by doing 180 minus 80 minus 30. So that's going to be 70 degrees for this whole big angle here. So we could use the sine law then, because we have this side angle pair, to find the length of the tree that's broken over here that we're looking at here. So we could call that x. So since we want to find x, we can do x over the sine of the angle opposite in that big triangle is equal to 100, side of the big triangle that we know, over the sine of its opposite side. And then we can get x pretty easily here. So just using our calculator, 100 times the sine of 30 divided by the sine of 70. So I get 53.209. I'm just keeping a few extra decimal places because I'm going to use this number again in a minute, and that would be in meters. So now if I just look at this triangle here, so I'm going to highlight it so you know the triangle I'm talking about. So if I'm just looking at this right angle triangle, I now know side x is 53.209 meters. And I want to find side h in red, the red side h right here. So this is a right angle triangle, so I can use SOHCAHTOA. So according to the 80-degree angle, this would be the opposite side that I'm trying to find. And then across from the right angle, the side I just found is the hypotenuse. So I want the ratio that has opposite and hypotenuse involved, and that's the sine ratio. So I can do sine of the angle, which is 80 degrees, is the length of the opposite side, which is h, I'm trying to find, over the hypotenuse, which is 53.209. And then I want to get h by itself, so I'm going to multiply both sides by 53.209. And then using my calculator, I get that the height there is approximately 53.209 times the sine of 80, which is 52.4 meters. And that's all they asked for, determine the value of h, so therefore h is approximately 52.4 meters. So that's the last problem we're doing. There's a little chart here that may be helpful for people. To solve an oblique triangle, so one that doesn't contain a right angle triangle, you need to know the measure of at least one side and any two other parts of the triangle. So there's 4 cases that can happen. You could know 2 angles in any side, but if you know 2 angles, you actually know all 3. You can find a side using the sine law. If you know 2 sides in the contained angle or side angle side, you can find that opposite side to the angle you know using the cosine law. If you know all 3 sides, you can find any angle you want using the cosine law. And if you know 2 sides in an angle opposite one of them, you can find an angle using the sine law. So that chart may be helpful for some people that aren't, when they initially have this out, when you're going through the problems that you're about to try, the practice problems, and you're not sure which formula to use. But remember that for right triangles, you use SOHCAHTOA. Remember that there's always 180 degrees in every triangle. And also with right triangles, the Pythagorean theorem works. And for oblique triangles, so non-right angle triangles, you definitely cannot use SOHCAHTOA or the Pythagorean theorem. So this is just right triangles over here. But you can use the sine law. But to do that, you need a side angle pair. Or you can use the cosine law. And you use the cosine law if you're given all 3 sides, or 2 sides and the angle in the middle. So with all that information there, it doesn't matter whether you're given a right triangle or an oblique triangle, you should be able to find any side or angle missing. So your success criteria as you try to work through the practice problems from practice 23 are that you can use appropriate trig ratios to find missing sides or angles in right triangles. So that's SOHCAHTOA. You can use the sine law and cosine law to find missing sides and angles in oblique triangles, and you can solve problems effectively using concepts from both right angle trigonometry and the sine law and the cosine law. Thank you.